All right. Thank you so much, folks. I can do a quick recap of the session past. This is the second session in our Accelerating GraphQL Federation Journey webinar series. And we are going to take a look at how to combine multiple GraphQL schemas using GraphQL Mesh here. For those of you who haven't looked at the list of participants today, we have Uri from the Guild. They are the makers of GraphQL Mesh. So it's fantastic to have Uri here with us. And we will be showing you how to kind of combine different GraphQL schemas using GraphQL Mesh. So that's what we'll do today. And before we get into the demo, one of the things I wanted to quickly do is a recap, as this ugly graphic here shows. We want to quickly recap what we were talking about in the previous session. And a key part of your GraphQL Federation journey is going to be the process of building subgraphs over different kinds of data sources. It could be a database, it could be an existing microservice that you have on another data source, and you might want to have independent subgraphs that need to be kind of federated over. And this journey involves a lot of effort at the subgraph stages, and then some effort in the federation stages as well. What we've seen from our work with users in the community, our customers, and so on, is a lot of effort. About 80% of the effort typically goes into building the subgraphs, and 20% of your effort is focused at the federation stages. So clearly, if you want to kind of realize your returns from your investment into federation, into kind of building a supergraph, so to say, you might want to focus on how to build subgraphs faster. And we've seen folks kind of do this in this journey in multiple iterations. You kind of build your subgraphs in a manner that kind of makes sense to you. You do your federation. You try to kind of benchmark the benefits that you've had from GraphQL. You're overjoyed because we've seen people who've kind of realized about their API delivery speed kind of go 2x their normal speed and so on. And they're like, okay, how can we go faster? They start to look at their subgraph tooling, and then they start to look for options to make that even more efficient. And what Hasura does is kind of help out folks who are starting their GraphQL journey, or people who have kind of done one iteration down this journey of federation, and people who are looking to optimize that even further. So what Hasura does is it kind of takes the undifferentiated work that goes into building a subgraph or to write a microservice, the operational effort, so to say, and kind of automates that, right? Things that nobody needs to write, grunt work that no one wants to do, things that include simple I/O between your client and the database. That's a general concern. Nobody needs to write any boilerplate code for it. And Hasura kind of saves you the trouble of doing that. That's a big chunk of it. There are other concerns as well, some API management features like caching, support with scaling, some security features, and so on, and also authorization, which is a big part of business logic that one might write. So Hasura kind of takes care of that part of the journey and lets you focus on the things that nobody can write for you, which is customized business logic that works for your organization and for your product. This pink box here could admittedly be slightly bigger, but the point being made here is that the undifferentiated concerns are kind of taken care of by Hasura when you're trying to build a subgraph, and that kind of helps speed your kind of point of nirvana with GraphQL Federation. So I think we have David here. David, thank you for joining us.
I think, as Sandeep said, this is a continuation of our January webinar, whose topic was or is GraphQL, combining GraphQL schemas from supergraphs, subgraphs to supergraphs, and we had a demo there last week, and we'll be continuing that in this talk.
David, before you get started, I just want to talk about something that we did not talk about in our last webinar, right? Which is your GraphQL maturity stages. And this
Yeah,
is for folks who are curious about GraphQL or at some stage in the federation journey, right? I think if you kind of track the previous webinar and this one, um, you kind of go from as an organization or as a single team, trying to build a single subgraph to kind of validate your hypothesis around
right,
GraphQL and the benefits that it can deliver. You can kind of represent this effort by a simple query around, let's say, authors. Like that, let's say we have in our example, we will cover two subgraphs for one each for author and articles, right? So let's say you start off with kind of building a subgraph around authors. Let's say that comes from a particular data source. You build your GraphQL subgraph over it. You test it out. You train your team. You learn from the various resources that you can find online, and you head to production with this GraphQL API. So that's the first step in your journey in trying to adopt GraphQL. And over time, any organization is kind of going to go from left to right on this kind of maturity phase, right? So you might want to have multiple subgraphs. You could have a subgraph for articles, and you can query them both independently, separate queries to kind of do that. Two different endpoints. What I wanted to convey here with these two queries is that you could have two different GraphQL servers or GraphQL endpoints kind of supporting each of these subgraphs. And then the next stage in your journey could be to kind of stitch these schemas together into a unified GraphQL API. Nothing dramatic here. It's just a simple union of GraphQL schemas. There's very low risk of any kind of regressions or schema integrity risks being introduced here because you're just kind of combining two schemas. You're just doing a union over two legitimate GraphQL schemas. And as long as you have simple namespacing, capabilities, you avoid collisions. There's very low risk of your API actually breaking as you kind of iterate on these two schemas, subgraphs independently. There's not a lot of collaboration that is required across teams because you can have independent release cycles, and the union can be achieved through very simple tooling. Um, and the next stage in your journey would be the most obvious thing to do, which is you have two subgraphs, they could be related. You define that relationship, and now you're able to kind of, in the same query, have a hierarchical or a graph response coming through from your GraphQL API, and therefore kind of achieving the original intent of kind of building a graph API, right? So things get a little complicated here. I don't want to go into a lot of detail around this. You understand what this will involve. Teams need to work together. This is your standard microservices integration problem. There's a high risk of breaking changes, which is why integration testing and all of those concerns are very important. And the tooling becomes critical, and performance becomes critical as well. David, thoughts on this evolution and what we are going to see here, and if you can cover what we saw in the last webinar, that could set the platform for
absolutely,
folks for your
absolutely.
domain.
Thanks for that, Sandeep. Yeah, uh, agree with all of that. One detail that we will get to is when we're at the highest level of this maturity curve, where we're composing schemas, but also stitching together types and relationships among them. We want to pay careful attention to performance, right? We're getting into the realm of distributing queries across systems, and it's one in between the third and the fourth level, there's a level where you're stitching together, you're combining schema and relating elements in a possibly naive way. It gets the job done, but we want to go a little further with that and have systems that do this efficiently. And we'll see that we can certainly see that in Hasura in the way that it brings together graphs, and we'll also see that in the way that GraphQL Mesh does it as well. So that's what I'd say about this maturity curve. And then, like I said, this webinar is a continuation of the one we did in January. The one in January was probably, I think, maybe level 3 on this curve. It was bringing together graphs, subgraphs produced through Hasura, with GraphQL Mesh. And in this continuation, we're we are starting to relate elements so that we can have hierarchically nested queries and be able to perform those queries in an efficient manner. So it should be a, you know, uh, it should be easy. It should be the one of the objectives of this is for it not to be hard. This should be easy, and if the demo God's willing, it should be a fairly quick demo. Um,
Understood. David, and maybe towards the end, we can also kind of do a quick revisit of the process of generating the subgraph, just to kind of, again,
Absolutely.
uh,
Yeah.
at the risk of belaboring the point that, subgraphs can be made easier and the federation part is relatively easy. All
Mhm.
right, with that, we will move to the demo. David, over to you.
There we go.
We can say.
Just for folks on the call, I think this has been distributed or will be distributed. We keep a lot of GitHub repositories with demos and examples here at Hasura. This is one that I have. This has, this has you can see here. This has talks and webinars that I have given in the past, and more will be coming in the future. In this repository, David A. Venimilia Talks. And within that, there is a subdirectory for this webinar, Hasura webinar, January 2024. You might be looking at this and wondering why does it say January when this is February? Again, this is a continuation of the webinar that we did last month. Um, just to orient you. And by the way, we probably will have some time in this webinar if we want. We could just a preview. I'll be running through this demo using some tools locally on my computer, Docker Compose. Hasura has a self-hosted option. There's a community edition. It's very easy to run locally. But you can also do this in the cloud, in our Hasura cloud platform. And maybe I will, at the end of this, adapt this and run off and do it in Hasura Cloud. But right now we're doing it in this with code that's in this local directory. There's really not much to it. There is, this README, which I won't dwell on right now, but it lays out the what we're doing. We are combining subgraphs into a supergraph. Subgraphs produced with Hasura, supergraph produced with the help of GraphQL Mesh from our friends at the Guild. Why we're doing this, again, I think Sandeep, you talked about this. GraphQL is one of its virtues. It's a highly regular, machine readable query language. That's why there's been an efflorescence of all of this tooling. Um, and so that we are blessed with multiple options for combining schemas together. And we can, um, it's an evolving process to figure out which components and which strategies work best. There's schema stitching. Hasura has its own Hasura remote schema way of combining subgraphs. There's a Apollo Federation, and then of course there's the GraphQL Mesh from the Guild, which we'll be demoing here. So there's the why. Um, there's some details. Well, what is in this demo? Well, we have some subgraphs over some data, so we need a database. There's a Postgres database in here. We have some subgraphs, like I said, produced by Hasura. We'll review that towards the end of this, but we are combining graphs. So there are two of them, two subgraphs, GraphQL Engine 1 and GraphQL Engine 2. Now, and I'll show you this in the code. Hasura, to produce subgraphs, it is pointed at databases. In this case, these instances of GraphQL Engine are pointed at this Postgres database. In a real world setting, probably you will have different business units. They will have their own data sources. These data will have to be, there will have to be some work done to make sure that that the data can be related. Very simple thing. Primary and foreign keys, identifiers. You got to make sure that those things match up. And there's a sideband work to make sure that that happens. In this demo, the easiest thing to do is just say, you know what, we're going to have both of these graphs. They're going to point to the same database. That takes care of primary foreign keys, makes it really easy. And then we will have an instance of GraphQL Mesh, which is that supergraph. It's that gateway. Let me make this a little bit bigger. This is probably a little bit easier to read for you.
Yes, now it
Yep,
is
there we go.
relatively. Yeah.
There we go. I have a high res screen, so it makes 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 life great for me and rough on webinar attendees. So we'll pump up the the font size. Uh, Simple data model, online, same as in the last webinar, online retail grocery store. There are, account holders who can place orders. There are there's an order table which has it's an invoice, right? And then associated with its usual thing, there's a mapping table for the invoices. There is an order detail table that has the actual details of an order. How many items are you buying? When did you buy them? There's a region table that's sort of to map these into marketing or to sales regions. That's not really important for this. Um, but then
David,
we
I have
have,
a
yeah,
question
yeah,
for
go
you.
ahead.
So this is a schema in Postgres, and does this demo also kind of include the init scripts to load the schema and maybe some test data into Postgres? Can I do a Docker Compose up and expect to have both of these subgraphs ready to interact with um, the
You
schema?
can, you can. So here's our friend Docker Compose, right? That sets up our
Understood.
our
All right.
services. We'll just take a
All right.
peek there for
Got it.
folks who are familiar with it. It's not very profound. There's Postgres. There's the first GraphQL engine. There's the second one. But the fun part is we are, where is it? Here we go. One of the volumes
All
that's
right.
mounted into the Postgres container
Mm-hmm.
is this initdb directory. That just means that whatever is in this directory, these scripts will automatically be executed by the
Okay.
Postgres container. And right immediately we say, hey, there's a SQL file to set up the model.
Right.
Ooh, ugly database
All right.
tables.
Got
There
it.
is um, a script to set up some seed data. Ooh, account holders. We'll get to the bottom. There's grocery store items. So there's seed data, um, and then there's fun fact. You know this, Sandeep.
Mm-hmm.
Hasura has a metadata database. Um, to make life easy, I'm just reusing the same Postgres host as the
Right.
metadata database for these two instances, but they've got to have their own databases. We don't want the metadata to conflict, so we do a little bit of work to create those databases. Nothing too dramatic. Does that make sense? Again, Sandeep, I'll use you as my rubber duck sounding board. Does that make sense?
It does make sense. So there's
Wonderful.
some underlying details that Hasura needs. So that's what the metadata DB is. I'm going to
Yep.
ignore that when I try this out. But what's important is
Yep.
if I run this Docker Compose file, I have a database that is ready to use. And for
That's
the
right.
benefit of this demo, we are reusing the same database for the two subgraphs. And we have two Hasura instances that can generate that subgraph. Um, it's easy to kind of test these individual APIs out, and we are now ready to combine these schemas in GraphQL Mesh.
We are, and I will point out for folks can you can clone this repository, you can download this code, you can try it out yourself. Probably in the history of the universe, no one has ever actually tried to run a webinar demo on their own, but maybe someday that'll happen. And if you do want to do that, um, one step, you know, there are some variables that are defined in the Docker Compose file, just some port numbers to expose for these services. I don't hard code those. Those are variables. Um, so there will need to be either environment variables set up for the Postgres port, for the Hasura port for the first server, the Hasura port for the second one, for GraphQL Mesh. Easiest thing to do is to put those into a .env file. Obviously, we don't check .env files into source control. Same reason we don't check passwords into source control. But there is at the bottom of this, towards the bottom of this README, there are some steps that you can take. Check out the repository, move to this directory, and create your env file, right? So choose your ports. Um, so does that make sense, Sandeep?
It does.
All
It
right.
does.
So why don't I'm gonna, if you don't mind, I will flip over to um, my favorite editor, and Sandeep's least favorite editor, Emacs. So this is that same directory, Hasura webinar, January 24, 2024. Here is our Docker Compose file with those services. There again, ah, there is the Postgres database. There is Hasura GraphQL Engine 1. This is moving too fast. GraphQL Engine 2, and then down at the bottom, and let me pump up the font size here. This is where the magic happens in GraphQL Mesh, right? So there's a Docker service for this as well. And in order for there to be a Docker service for GraphQL Mesh, there is a Docker file to create a Docker image for GraphQL Mesh. I know that there are already GraphQL Mesh Docker images. I think our friends at the Guild probably even provide them. But I decided to just do this the hard way. Yeah. So there's one of those. And I got my env file. So let's just see if this works. So we are launching the services that will include the database, these two Hasura instances, and GraphQL Mesh. And while that's happening, let's take a peek at. You want to take a peek? Let's jump ahead and let's talk about GraphQL Mesh while that's happening. What do you think of that?
Let's do that. We
Okay.
can maybe also see if Zach can invite Uri to participate. I'm not sure if participants can unmute themselves and so on. But we're good to see if Uri can join. But go ahead, David. Don't
Wait,
interrupt
Sandeep,
yourself.
way to put Uri on the spot.
I know.
He
Really sorry
just
about that.
he just dropped. He'll probably just drop out of the webinar right at this moment. No, that would be great. But uh, I would welcome the input because our friends at the Guild, they are the experts with GraphQL Mesh. But there is everyone has a configuration file. Um, GraphQL Mesh has its configuration file. And why don't we head over to the GraphQL, not graphing calculator, GraphQL Mesh. There we go. Documentation. Uh, so, um, I'll deliberately say some things that are wrong that will provoke Uri into really jumping onto the call. Um, uh, but GraphQL Mesh is hey Uri. Um, what I was going to say is GraphQL Mesh is it's a kind of gateway over heterogeneous data sources. It offers a number of services, including the ability um, to bring together heterogeneous data sources. By heterogeneous, I mean they can be GraphQL, they can be REST-based services, they can be databases. Um, it also offers services on top of that. You can use GraphQL Mesh to shape and curate the API that you're producing, right? You can transform elements of the API that you're producing through transforms and plugins. Uh, there are non-functional concerns that are made available through GraphQL Mesh, like caching, I think security, and other services as well. Have I sung the praises of GraphQL Mesh enough? Um, I love it. I think it's great. Um, Uri, is there anything you want to add to that?
No, I don't
I left you speechless, I think. Um, anyway, um, so that is GraphQL Mesh. But what I wanted to point out is getting back to the code. Um, and GraphQL Mesh has a um, a plug and play approach. There are different components that can be added into it. Um, and Those include source handlers. So it has the concept of sources. So in this config file, we're defining two sources of data. Those sources, again, they could be databases, they could be REST APIs. In this case, they're two GraphQL subgraphs coming from Hasura. One of them is basically what I've done is here. Why don't I one second. I've got a port conflict. So the simplest thing to do there is make sure that I don't have any Docker containers running. Let's kill those. Let's try to get these services launched again. Oh, look at that. We are inserting data into a database, and these services are coming up. That's good. The reason it failed earlier is I had another instance of Postgres running on that same port. One other thing I want to point out is Sandeep, Hasura, as we mentioned, Hasura has metadata that is used within Hasura. It's GraphQL Mesh has configuration. Hasura has configuration. For Hasura's configuration, that's metadata. There are a number of ways that can be brought into Hasura. One convenience is we do have versions of our Docker containers, the CLI migrations images, which will automatically apply metadata. So once that's done, the metadata for these two instances of Hasura, which are in GraphQL Engine 1 metadata and GraphQL Engine 2 metadata, those are being applied automatically. So with a little luck, let's take a peek at those subgraphs. So localhost 8081, that should be the first subgraph. What do we have here? This is what I'm calling catalog. So this has just the grocery store product information, right? It's just products. What kind of products do we have? Let's take a peek. Let's just get 10 of them. Grocery items, no big surprise. Localhost 8082. We have accounts. And within accounts, there are orders in some region with a status. There are order details. Some number of units of a product is being purchased. But deliberately, I've omitted the product table from this subgraph because we want to bring in, we want to bring this in through GraphQL Mesh. So in the subgraph, we can see accounts, orders, and order details, but we don't see the actual products. But that will happen through GraphQL Mesh and its schema stitching. So why don't I now, to add some other excitement to the mix, it's useful to have some kind of GraphQL graphical client. There are many choices out there. If you launch GraphQL Mesh in dev mode, you'll get one. It'll just present one to you. Hasura has Hasura Console. In this case, I'm using another one called Altair. It's the same principle. And what I want to do is I want to point this client at the supergraph. I want to point this at GraphQL Mesh. So where's GraphQL Mesh? Well, if we go back to our demo code, it's one of the services. Here it is, GraphQL Mesh at the bottom. Its own port of 4000 is being mapped to something. What is it being mapped to? Looks like it's being mapped to 8083. Okay, well then this must be HTTP local host 8083. And I think the route is GraphQL. Okay, reloaded docs successfully. That looks good. Okay, so we should be able to dispatch queries here. Query account. For the account, let's get name. Let's limit this to let's just say 5 accounts. We'll get the orders. For those orders, we will get, how about the region that it's in and the status? But we want the order details. So far, we're still in one subgraph, right?
Right.
For the order details, we might as well get, let's get units. How many of this thing were purchased? But now we can get product. We couldn't get product from the Hasura subgraph because it didn't have product. That was in the other subgraph. But GraphQL Mesh is composing these together into one schema. And it's that fourth level in your hierarchy where we're, a simpler way of combining this would be simply that one can, within the same endpoint, you can query for accounts, orders, order details, and products, but not the products for an order. In this case, we can actually get the products for an order. And let's just get the name and price, I think. And there we go. So looks like Estevan Lemming made an order in the Midwest for brown sugar, baby spinach, and watercress. Gross. So not very profound, but now I want to, but this, it takes a lot of work to make it look this easy, right, Sandeep? So there's been a lot of effort within Hasura in order for to create the ability to create these subgraphs over a wide variety of data sources and add those non-functional concerns again, caching, security, authentication, JWT termination. Likewise, there's a lot of effort from the guild in GraphQL Mesh to offer the ability to bring these components together.
David, are you going to show what this configuration is going to look like? How did you kind of do this? What does the relationship definition or the composition look like?
That's right.
Okay.
Yeah, here we go. So we're back into this is the config file for GraphQL Mesh. We've defined our sources, and you can see right here. It has the concept of a handler. We are using a GraphQL handler. There are handlers for Postgres databases and OpenAPI endpoints. In this case, we're using 2 GraphQL services.
Right.
And then there is this is the moneymaker, the additional type defs. This is where I said that GraphQL Mesh gives users the ability to shape and curate and modify the supergraph that they're producing. So this extends the order detail type with an additional field. Natively from the subgraph, order detail doesn't have a product field. So we're adding one, right? We're adding a product field, and we are adding a bit of configuration that lets GraphQL Mesh know, well, how do we go about this? How do we
this product?
That's right. And this reminds me, I'm actually doing this twice. I'm adding 2 fields. I'm adding the same data twice. There's product and there's product batched. And I did this because I wanted to point out this distinction between a less optimal and a more optimal approach for joining data. There's a very straightforward way in GraphQL Mesh where you say, well, I'm adding, there's this resolve to directive. It takes some number of parameters. We're saying, well, how do I resolve this? Well, you go to the catalog source, and then off of the query root type, you will find a product by primary key field. That's all true. That's provided by virtue of Hasura. And to fill this out there's a little bit of head scratching where you have to look at like, well, what is the API of your subgraphs? And then you think about, well, okay, how do I adapt this to what GraphQL Mesh is expecting? But you and I know that there is a product by primary key field in Hasura that takes a primary key, the product ID. It's right here. And then there's some configuration that tells GraphQL Mesh, okay, well, where do I get the value for that parameter? Well, you get the value from the root of the query, or the root of this type rather, which is order detail. And I know that order detail has a product underscore ID field. That's the relating field. So this is the part this is like a primary key foreign key relationship. This is the part that says, hey, the product ID field here
Is
is
mapped
passed
to
into um, the
right.
input to that um, field, and that's all great. But Udi can correct me if I'm wrong. If we do it this way, for every order detail that we encounter, a GraphQL request for one product will be issued. So this is the
N
the
plus.
dreaded N+1 problem, right? So how do we get around that? Well, it so happens, you and I know this, that Hasura, among the many features that it offers, is we support, depending on the database, many additional operators for accessing data, right? So there is, in addition to selecting data by primary key, product by primary key, just off, and I'll show this in the Hasura subgraph, just off product, there is an in operator that is supported. You can pass in an array of IDs, a batch of IDs, and get all of the items within that in one query. And GraphQL Mesh can use this. So that's what we're doing here. Same thing, we're saying, well, add to the order detail type, add an additional field, product underscore batched. Same thing. There's a resolve to entry. We say go to the catalog schema, again, from the query root. This time look for the product field. Again, it takes product ID. And then there's these attributes here, the key field and the keys argument. And I'll show you how I'll show you what those relate to in Hasura. So if we head back over to, remember, there are two subgraphs, localhost 8081 and localhost 8082. 8081 has the product catalog.
Right.
So this is the one that we're interested in. Hasura provides on the query type these top level fields for every single table that you track in Hasura gets, unless you make a few other choices, gets top level fields like this. So for the product table, you can do aggregate queries. You can search by primary key, but then right off product itself, there is very helpfully a where parameter. And for the attributes within that, we support quite a few operators, equals, greater than or equal to. And the one that we're interested in is in. So if we use
These look
this, yep,
I mean, these look eerily similar to the operators that Postgres supports on a certain kind of column.
yep,
Maybe we can like talk about how you get these operators, these GraphQL operators, after you can finish this point. I'd love to see, like,
yep,
if I bring in a new table, what does Hasura do to that table? How do I get these resolvers for free and reduce
that's right.
that probably 80% of the work? So,
Yep. Yeah, I'm pretty much done with this discursion. So this approach within Hasura to use its in keyword to pass in, what you end up passing in here is an array. You can pass in an array of IDs, and Hasura will fetch all of the products for those for the elements in that array. And so that's what we're using here. We're saying, well, we know that there's a where parameter, and it takes moreover, it takes an in subparameter. There it is. There's where. Actually, so it's where ID in. So there's where ID in. And the keys will come from product ID. So if we head back over to Altair, and there's probably a better way to explain how that's being done. I'll go back to GraphQL Mesh School, and hopefully I'll have a better way of presenting that. Okay, so we have product. What about product underscore batched? There we go. Great. So that works. For these tiny amounts of data for these demo, you won't really notice the difference, 35 milliseconds versus some other possibility. But this will become important for
Real world
queries that are
databases, I
traversing.
guess, with thousands of rows, and
Yeah, that's
especially
right.
as
Real world use cases.
the graph starts getting complicated, right? Like if you have 3 levels of nesting, and then you're suddenly making n+1 into God knows how many
That's
queries.
You were requesting that maybe we revisit how easily and how quickly how is it that we can bring these tables into Hasura? So we're back into this subgraph, the catalog subgraph. We know that this. Yeah, go
David,
ahead.
so I have a question. So we did a recap where we were talking about, hey, when you're normally building subgraphs and then federating, the distribution of work is 80% of effort goes into building subgraphs, 20% into federation. So what we just looked at is your demo of the 20% of the work, where you specified the sources or to the subgraphs, you specified some declarative configuration, and that was enough for Mesh to be able to provide this unified layer. Um, and I mean, sure, there's a lot of learning that you had to do to be able to do that. But if you had to do this further for another set of types, the effort that will go into doing this would be very minimal,
It's a
right?
very small
Compared
amount of
to
effort. That's right.
understood. And now what we're trying to do is we're kind of going back to one of the pieces of the demo that we did in the previous session, which is talk about how you can save time building subgraphs instead of writing DIY code, instead of using libraries like, let's say, Netflix DGS if you're a Java shop and so
Sure.
on. How could you quickly generate a subgraph over, in this example, a Postgres instance, and if you're interested in other data sources with those two with Hasura. So just wanted to set the context of that, David. Over to you again.
Yep, that's right. So within this subgraph, up until now, it only has the product table tracked. That was deliberate. That's so that I could create this sort of ersatz example where I have to like stitch these things together. But we know that this instance of Hasura, it's actually pointing at the same database. And Hasura introspects databases. It shows you the objects and the tables that are within it. And with Hasura metadata, you can also shape and curate the graphs and the subgraphs that you are producing. One of the ways that you do that is you choose which data items to track or to expose. Here are those other tables that are in that other subgraph. We could track them here, right in this instance as well. And it's, for folks who are familiar with Hasura, this is bog standard. This is boring. It's just this easy. So I've tracked those tables. Hasura has the concept of relationships among the types that it produces. You are not required to have primary key, foreign key relationships in it. If it's a relational database, you can create relationships among attributes within your database, even if there aren't foreign key relationships. But if there are foreign key constraints, Hasura will helpfully introspect those and suggest those as possibilities, which it's doing here. So we'll track all of those relationships. Relationships are that's one of the most important aspects of Hasura and of these graphs, right? Without relationships, you have a bag of types, but those types aren't related to each other, and you have a very shallow, superficial graph API. It's not really a graph, and you can't really do much with it. It's a glorified REST API. So relationships are what give you those edges and gives you a bona fide graph. So that's it. It's just that easy. And then, of course, there are those
So
sort of additional services that we provide on top of this. Permissions, a whole permission system. There are options for security, caching, data integration through remote schemas, integration with REST APIs through actions, asynchronous business logic processing through event triggers, a lot of services that we offer. So that's pretty
David,
much it for the demo. Yeah.
could you show me the API? So you did a
Yep.
bunch of things in the Hasura console. You tracked a table.
Yep.
I now have orders table in this subgraph as well.
I do.
So as far as my subgraph building journey goes, I told Hasura that, hey, here's a database. This database has, let's say, the orders table. This subgraph already had products, so maybe the orders table is what I'm interested in. As part of my feature iteration, I need to bring in this orders table, and I need to include this in my subgraph. So you tracked it, and what happened next?
What
Like, do I
happened
get to
next is,
query it instantly?
yeah. So what happened next, if you recall, there once was a time where there were only top-level fields for product, but now we have top-level fields for account, order, order details, and so we're now doing the same query that we did back in Altair
Right.
through GraphQL Mesh, through GraphQL Mesh's composing of schema, but we're doing it right within the subgraph because I've made the choice to actually
Right.
To track these. In a
Understood.
real world setting, you won't really have that option because there will be different databases in different business units,
Right.
and that's where something like GraphQL Mesh becomes really important. So there's order details,
I see a
and
lot of top level fields here, though.
yeah,
You tracked one table called order and one table called order details, and
yep,
I see orders, I see order by PK, I see a whole bunch of things. Is that
right. So by default, Hasura will give you for your tables top level fields for the type itself. So let's say order, right? And this is kind of it's like a generic interface to that type. You can fetch instances of it. You can apply predicates. There's a where attribute. You can provide parameters through there. We also add a type by PK top level field. It's more like a special purpose. There's nothing that you can do with order by PK that you can't do by just using the where parameter,
right?
choosing ID and equal.
Same.
But it just saves you a little bit of effort because as an API consumer, I might come into this and say, well, hang on a second. I mean, I can guess. I know one of these fields is probably the primary key, but I don't know which one it is. Which one do I use?
Right.
It's probably the ID field. This just saves you the trouble. You have a guarantee that this one is actually using the primary key. So
And
again,
maybe the index on it, and I can enforce that this is like a more efficient query and
right.
so on.
So we
That's
give you a generic top level field for the type order. We give you a specialized order by primary key, and then we give you a top level field to start performing aggregations over those data, right? You can say, well, what do I mean by aggregations? Well, database aggregations, count, say max of these attributes.
that's pretty nifty.
Yeah.
So as a rubber duck, right? What I'm seeing is that for any kind of given table, you kind of generate potentially all permutations of the types that you might need on a given model or table. And I'm seeing a lot of familiar SQL terms here as well. So
that's right.
is Hasura kind of leveraging um, the database to provide me a rich kind of interface, like a rich set of types on the underlying tables?
Why, yes, it is. Good question. Hasura is,
That's
as we know,
surprised.
it's a among other things, at the core is a compiler, a transpiler of GraphQL to underlying query languages. For relational databases, that will be SQL. For let's say Neo4j, it might be Cypher. Um, for many of our data sources, which are relational databases, it will be some version of SQL. Postgres dialect of SQL for Postgres, Microsoft SQL Server's dialect for Microsoft SQL Server, so on and so forth. But it's leveraging the um, the engine underneath to produce efficient queries. That's what's happening. And to your point, it saves the effort of writing that boilerplate code in Kotlin or Java or what have you to
Right.
to get there. That's right.
All right. Okay. This seems
Sandeep, let me ask you,
relatively.
what do you think of, so if we head back to, if now we go back to GraphQL Mesh itself,
Mhm.
and this concept of schema composition, um, uh, to bring these schema together, to compose these, we have to
Mhm.
layer in some additional metadata, right? That tells the processor, well, how do I combine these? In this case, the metadata is how do I relate these fields? Um,
Right.
that metadata there are a lot of options for where that metadata could be. It could be in a config file, it could be in a database, it could be in the subgraphs, it could be in the gateway.
Right.
GraphQL Mesh, like Hasura, has the approach where that configuration goes in the gateway. Um,
Right.
what do you think are the benefits and or any drawbacks of doing that? Or what are some consequences of that?
I
Well,
think the way I would think about this is like if I look at my journey, right? We looked at
yeah,
the maturity curve, right? So I first start building a subgraph, and then I start to federate over them, right?
right.
You may of course run into situations where you know that you're eventually going to federate over them, and if your choice of tooling requires you to add directives and so on, you can take care of them early on. But the organic journey for most people begins by building the subgraph and then looking at tooling to kind of implement the federation layer. And if you don't have this additional type tests or the type extensions happening in a separate place, you almost always have to go back and change your subgraphs. And in typical enterprise, these subgraphs are usually spread across teams. I mean, by definition, each team kind of owns it's not by definition, but by convention or practice, each team kind of owns its own subgraphs. You want independent iteration streams and so on. The fact that somebody needs to coordinate with multiple teams kind of goes against the that principle of letting individual teams iterate as they need. So I like this. I mean, of course, I'm biased. Hasura also kind of has federation metadata that lives outside of the subgraph, so to say, right? Very similar to the design choice made by the guild as well. So for me, that's, I think, just right up the top of my head, that's one of the drawbacks of requiring your subgraphs to hold on to that information. Um, but would maybe
Yeah,
Uri, if
that's you nailed it. That's, I mean, it was a leading question, but that's kind of what I was fishing for is one of the, and we're at time, so we can wrap this up. But yeah, I mean, uh, you may be in a position where, or not, you may not be in a position where you can actually add that metadata to your subgraphs and if that's where the
right,
metadata has got to go to get your composed schema, um, you're gonna have to
it
make other
complicates
arrangements.
things.
It complicates things.
Yeah,
So
yeah. I'd love to hear Uri's thoughts. Uri, again, sorry to put you on the spot. I seem to be doing this a lot in today's call. But if you would love to hear your thoughts on this, like why did the guild choose to have this kind of metadata live outside of the subgraphs? Any kind of design considerations that went into it?
Yeah, so with Mesh, actually, you can use that metadata anywhere. So you can have the data on the supergraph, you can have it as a separate config files, and also it could be distributed. So not everything needs to be in one file. You can, distribute the files, and it could be on the subgraph. So Mesh also supports like directives. So if, for example, you choose to specify some of this data on the subgraphs as directives, Mesh will also understand that. So we try to make Mesh as flexible as possible for all of these use cases, because like you said yourself, like different teams have different ways of doing it, right? Like you have parts of the ecosystem that prefer to put those ideas on the subgraph. Some people would actually prefer otherwise, because they would say it actually breaks the the separation of concerns between the services. So GraphQL Mesh tries to support both ways. Yeah, and so you can do all of those together. And I mean, it's really interesting to see how you how you use GraphQL Mesh from Hasura's perspective. I think we can think together about even like more easy ways to, I don't know, automatically take some stuff from Hasura and feed that into Mesh, or I looked, I was also working during the workshops. I didn't see anything.
No worries. We did put you on the spot.
And any feedback that you have on this, like we can collaborate together. I think it's really exciting just to see, the two teams working together. It's we always have good relationship. So yeah, it's very
nice tool. And Uri, I really do. Again, I appreciate that flexibility, which is evident in the GraphQL Mesh approach. The pluggable nature of it. It's a very flexible tool, and I definitely appreciate that. I have to run, but thank you all.
And especially to Uri as well. Thank you so much for joining on such short notice, and also kind of participating with the rest of the community. Really appreciate that. Thank you so much. And thank you everyone for joining the webinar, and see you again soon.
All right. Cheers. Bye-bye.